Hi, everyone. Welcome to today's Tech Talks. My name is Roberto Canton from Microsoft. And today I have my friend from VMware, Victor Sandova, as well as our friend from our customer and success unit at Microsoft, Mark Godfrey. Today's topic is advanced networking with Azure VMware Solution. This Tech Talk is part of our series of Tech Talks that we have been building as far as our Azure VMware Solution Academy. It consists of interactive live and on-demand sessions designed to illustrate and upskill or migrating, extending, hosting, modernizing applications and workloads through and with Azure VMware Solution that is available as a Microsoft Azure Platform Service. You can see the link there on the screen where you can have access to all of these future sessions as well as some of the recordings. Like I mentioned earlier, from a speaker's perspective, we have Victor Sandova, who is a senior staff cloud solutions architect at VMware, and he's fully dedicated to nothing but Azure VMware Solution for VMware. We also have Mark Godfrey from who's a senior customer engineer in our customer success unit here at Microsoft. And myself, Roberto Canton, I'm a solution architect in global partner solutions for the US here at Microsoft as well. So from an agenda perspective, what we have is we're first going to go over an overview of Azure VMware Solution. Then we're going to kick it off to Victor so he can talk a little bit to us about the NSXT networking inside of AVS and some advanced topics in that area. Then I am going to show you a little bit of basics of Azure networking for those of you that are not fully familiar with Azure yet. Then we're going to couple that with Azure networking with AVS. And to top it all off, Mark is going to be talking to us about Azure Virtual WAN, which is one of our Azure services, and how it functions and how it's set up with Azure VMware Solution. Then at the end of the presentations, we're going to have some time for some Q&A. So without further ado, let's get started. So AVS, Azure VMware Solution. Hopefully by now, most of you know what Azure VMware Solution is, but it's nothing but a VMware infrastructure or VMware environment running inside of the Azure data centers. You can run your VMware workloads natively as an Azure service. It's a first-party Microsoft Azure solution. The unit of consumption, the unit of measurement is the node or the physical server. As you can see here, we have three types of physical servers, AV36, AV36P, and AV52. So depending on your needs, you would select whichever option you want. Just keep in mind that you need a minimum of 3 nodes to consume the service, and you can add additional nodes as needed in your AVS cluster. The VMware software that comes as part of the service is what you see on the left here. So ESXi, vCenter, vSAN, NSXT, and HCX are all included as part of the cost of AVS. So whatever cost you pay for, let's say, your 3-node cluster, that will include the licensing for these items on the left. The items on the right, which is additional VMware software, is purchased separately from your friendly VMware account rep. So if you want anything like Site Recovery Manager from VMware or Tanzu Standard, Horizon for VDIs, vRealize, NSXT AVI, or VeloCloud SD-WAN, talk to your VMware rep and they can sell you the licenses or the appropriate cost to bring those licenses into AVS. Some benefits of AVS is the fact that you can get free extended security updates for your Windows Server 2008 and SQL Server 2008 workloads. 2012 is also now part of this option as well. If you or your customer are running any 2008 or 2012 workloads and you need extended security updates from Microsoft, you need to pay an additional cost for those to be provided to you. But if you migrate those workloads into Azure, including AVS, that cost is free of charge to you or your customer. We also have the Azure Hybrid Benefit Program, which allows you to bring those Windows Server or SQL Server on-premises licenses with software assurance directly into Azure. These two options I just mentioned are only available in Azure. From a payment perspective, you can. We have three different models. You can do a pay-as-you-go model where you pay by the hour. You stand up 3 nodes for 10 days. You only owe Microsoft 240 hours of the 3 nodes. But you can also take advantage of discounts for a 1 year or 3 year reserved instance. The 1 year reserved instance gives you 30% cheaper than the pay-as-you-go model. The 3 year instance is about 50% cheaper than the pay-as-you-go model. And those reserved instances are also exchangeable for any other Azure dedicated reserved instances. For example, Azure VM IaaS or dedicated host. So for example, if you buy 3 nodes for 3 years and after year 2, you no longer need AVS, but you still have a year left, you can exchange those reserved instances for anything in Azure. So for US partners, you know what the market opportunity hopefully is by now. There's about 500,000 VMware customers out there, about 70 million VMs running on vSphere, and the opportunity is just humongous to be able to bring some of those workloads into the cloud, especially into Azure. And some ways that US partners can leverage Azure VMware solution is you can resell AVS as an Azure Cloud Solution provider. You can build value through some ISV offerings that you may offer. You can also offer assessment services and tools, like, for example, Azure Migrate, which now supports AVS. You can drive and execute AVS POCs with customers, whether those be customers that you bring to the table or customers that Microsoft Field can bring to you. You can also offer professional services for AVS migrations and develop a managed service practice for AVS. And developing that managed service practice for AVS is basically that North Star that we're looking to you as partners to achieve with your Azure VMware solution specialization. You can talk to your TPS, your technical product strategist, or your PDM, your partner development manager, about achieving your advanced specialization on AVS, and we'll be happy to assist you with that. So that's an overview of AVS. We're gonna, I see some questions coming in. We're gonna address the questions at the end of the presentation. In the meantime, I'll pass the baton over to Victor, and Victor will present us with some NSXT advanced options with AVS. Take it away, Victor. You're on mute, Victor.
Roberto. So in this particular session, we're going to be covering 2 subtopics. One of them is the NSXT advanced topics, and then HCX networking, some of the things you have to take into consideration when doing migrations into AVS. All right. So first of all, let's talk about the overall layout of NSX inside of AVS. Now, when AVS gets deployed, out of the box, the architecture for NSX is a prescriptive one. So you don't have to worry about installing NSX or laying out things like the tier 0 or the tier 1 edge. For those of you that are not familiar with NSX, effectively there are 2 types of edges inside of your software-defined data center or inside of your private cloud. One of them being your tier 0 edge. This is the perimeter edge. This is owned and managed by Microsoft. Think of the tier 0 edge as the border between the physical infrastructure and the virtual space. The physical infrastructure being the Azure backbone and the virtual space being the subnets and the network segments that you're going to be creating from a day-to-day basis. Southbound of the tier 0 is where you're going to be doing your day-to-day management. This is what we call a tier 1 tenant managed edge. You can have multiple tier 1s if you want to, but for illustration purposes, I only have the default tier 1 that comes deployed when you deploy the AVS solution. Southbound of that, you can deploy as many subnets as you wish. In this case, I have 3 subnets for illustration purposes: a blue subnet, a green subnet, and a red subnet. Now, when it comes to firewalling, there are 2 ways that you can do firewalling inside of NSX. The first one is doing a gateway-based firewall. And basically, a gateway-based firewall is it's a firewall that gets applied on the tier 1 edge. And this allows you to basically It allows you the ability to filter traffic from a north-south perspective. So in this case, if I have a virtual machines on my blue subnet with the IP space of 200.0 with /24, that can be filtered by enabling the north and south firewall on the tier 1 edge. And also I can leverage this firewall for some east-west type of firewalling, in which in this case I have firewall policies that don't allow traffic to be applied on the green subnet and the red subnet. It's pretty straightforward. There's not much of a learning curve in applying gateway firewall services. So you have experience creating security policies on typical network appliances. This will be second nature to you, because effectively it's the same thing. You're just applying security policies on an edge device. The other option that you have for NSX is using the NSXT distributed firewall. Now, the NSXT distributed firewall is a little bit different. This is an in-kernel-based firewall. As Roberto mentioned, the minimum entry point for the software-defined data center is 3 hosts, and all the way up to a maximum of 96 hosts per your SDDC. The benefits of the distributed firewall is that because it is in kernel, the more hosts that you add to your cluster, the more compute power you have for creating security policies. So in this case, the in-kernel-based firewall basically is a firewall that lives between the virtual machine and a distributed virtual switch. This allows us to be more granular in the way that we apply zero trust security policies. For instance, I can create not just north and south firewall rules, but I can also create east-west firewall rules within the same layer 2 subnet. So in this case, I had 2 VMs living on the 200.0 IP space, and I can firewall them, or I can air gap them without having the need to deploy a network appliance between each of these devices. And because I'm intercepting the traffic between the VNIC and the distributed virtual switch, I also have the ability of being able to apply firewalls between different subnets, or also applying firewalls between north and south. So my recommendation to you is that when you're trying to leverage the firewall services within NSX, familiarize with yourself with distributed firewall. By far is the most powerful tool that you have available to you to protect your workloads. And once you get the hang of it, it's pretty straightforward applying distributed firewall policies. Now, for your customers that are hesitant to using NSX for the security policies, maybe they're already vested with a third-party network virtual adapter, like maybe they have Palo Alto Checkpoint, or they have Palo Alto, they have Checkpoint, or they have Cisco Firepower, etc. Azure has different architectures for you that you can apply for applying such security products inside of AVS. So there are a total of 3 options. I'm going to cover each one of them briefly. Option 1, things to take into consideration. In this particular architecture, basically what we are doing is we are deploying a third-party NVA. Again, it could be a Cisco Firepower or a Checkpoint, whichever firewall you wish. And basically, you are deploying this firewall southbound of the tier 1. So in this case, this appliance has, imagine this is a Palo Alto appliance. In southbound of it, we have 2 different subnets. We have a web subnet and an app subnet. The benefits of this is that it's pretty straightforward. You just deploy a virtual appliance, and the virtual appliance acts as the default gateway and also the firewall for all of your workloads northbound of the subnet. The considerations you have to think about is there's a limit of 10 network interface cards per appliance. And typically we use 2 out of the box. We use 1 for the uplink and we use 1 for management, which means that you only have a total of 8 usable subnets. So if you have a very small environment and you don't think you're going to need more than 8 subnets, then option 1 should be sufficient for you. But if you need more than 8 subnets, then or multiple security zones, then you probably want to take into consideration option 2. Option 2 is basically a layered approach into architecture. Southbound of the tier 1 would deploy again your third-party NVA. Then southbound of that NVA, you deploy another tier 1 router. And effectively what we are doing here is that we are each tier 1 router is its own security zone. So if you, for example, you have a production zone, a test zone, or a DMZ, or X amount of security zones that you want to define inside of your software data center, this option is probably the best one for you. Things to take into consideration: you can have up to a maximum of 8 security zones, but there are no maximum number of subnets. Uh, Theoretically, I believe the maximum number of subnets that you can have by a tier 1 is upwards of 1 million. You're going to run out of capacity from a compute standpoint before you run out of subnet space inside of NSX. In my opinion, option 2 is probably the most popular with customers, followed with option 3. Now, option 3 is basically when your customers come to you and say, I have an existing Palo Alto appliance, or I have an existing MVA inside of Azure, and I want to leverage this option for my SDDC. Well, in this case, you can deploy AVS in a hub and spoke model, and effectively, everything inside your software-defined data center will be one security zone. As the traffic leaves to the outside world, we can use things like route server or your V1 to basically filter this traffic to go to your existing MVA. And then from there, you simply just use your existing security policies that you have defined on that MVA appliance. Again, things to keep into consideration is that with this particular model, you are stuck with only having one security zone per software-defined data center. So meaning that if you have multiple security zones, like in our previous model, when you have a production, non-production, and a DMZ security zones, so this model will not apply to you. In order to make this work with multiple security zones, you will have to deploy multiple software-defined data centers for each security zone. Okay, so this covers the networking and security portions of this presentation. We are going to be following with HCX networking. Now, for those of you that don't know, HCX is effectively the tool that we use to migrate workloads from on-premises over into AVS. Now, 3 ways that you can leverage HCX from a networking standpoint. You can use HCX to re-IP your workloads, in which case I'm just going to explain to you how that works real quickly. On the left side of this drawing, we have the customer's on-premises environment being illustrated by 2 routers. The first router is used for routing your management components, represented to you by this green subnet. And then the orange and blue subnets are just your typical workload environments. On the right side, we have your AVS environment. Again, this is completely deployed out of the box. So this is a brand new environment. You have your tier 0 router, and then you have your tier 1 edge. And for illustration purposes, I created a red subnet southbound of this tier 1 environment. Now, the first thing that you want to do when you deploy HCX is pair HCX to your on-premises environment. So all you do is you deploy an HCX appliance on premises, and when you pair it to the HCX environment on AVS, it creates an IPsec tunnel. And this IPsec tunnel is being used to basically replicate all your components from a storage standpoint. So like the VMDK replication will be done through this particular tunnel. Now, when we're talking about re-IPing the workloads, you can tell HCX to migrate these via bulk migration or cold migration, in which in this case, when we are re-IPing the workloads, the first thing you want to do is create a subnet inside of AVS. In this case, I created this green subnet. And once I create this subnet, it's going to be advertised via BGP across your express route into your on-premises environment. HCX, once it migrates the workload, you can program it to re-IP the workloads as part of the migration process. So in this case, once the VMs get migrated, they get also re-IP to its new subnet in the cloud. Things to take into consideration with any migration when you're doing re-IP is that you want to make sure that you understand the application requirements and also the networking requirements, things like firewall rules and load balancing, as well as any stateful services like DNS and DHCP. You want to make sure that it's in place before you actually migrate the workloads over into the cloud. Not doing so could potentially break your application as part of the during the migration. If you don't have a good visibility into those requirements from the application, I recommend to you that you look into leveraging tools like vRealize Log Insight, which can sniff your current environment and show you the networking flows for the particular VMs that you're planning on migrating. Again, reIPing is probably one of the most popular approaches for migrating workloads over into the cloud. Another approach that you can take is migrating all of the workloads into AVS by the entire subnet. So in order to do this, it's similar to the reIPing process, but in this case, you are basically deploying a subnet. In this case, this will be your green subnet, but notice that this green subnet is not connected into the tier 1. Because it is not connected to the tier 1, that means that it's an isolated segment, and it is not routable. So what this allows us to do is to migrate all the virtual machines on a particular subnet without having to reIP them. So in this case, I'm going to migrate all of my blue VMs that are on this blue segment. And once I migrate them, as part of the migration process, I'm going to go ahead and connect this segment to the router, so that it goes ahead and it advertises the route over back to your on-premises environment. Things to take into consideration for this particular migration strategy is that it's only possible if the VLAN or the layer 2 segment on premises is only populated by virtual machines. It cannot be commingled with physical workloads, as those physical workloads will probably not be migrated into AVS. Also, this approach is only possible with small migrations. I'm talking about maybe 30, 40, 50 VMs per VLAN. If you have multiple, or you have more than that, you have maybe hundreds of virtual machines per VLAN, this is probably not a good approach for you, since it requires a significant network outage by the time it takes you to migrate those hundreds of virtual machines into AVS. Okay, but again, once the VMs have been migrated, the traffic just routes back to on-premises. Since this segment no longer resides on premises, then the segment now resides on the cloud. And same thing from an east and west standpoint, the virtual machines are now just using their tier 1 router as the routing standpoint, as opposed to using the router on premises. All right, let's cover the last topic for migrating workloads into the cloud, and that is a layer 2 extension. So same architecture as the previous two scenarios. We use HCX to replicate the VMDKs. But in this case, as part of the migration process, we are going to be doing a layer 2 extension. So what that means is that we're going to be grabbing the VLAN from on-premises, and we're going to extend that VLAN over into AVS. Now, by doing this, you need two requirements. You need to have a distributed virtual switch on premises. And you need to be running a version of vSphere that is 6.x or above. Once you have your layer 2 extension, as part of the migration process, you can do a live vMotion or a bulk migration. What that allows you to do is just simply migrate those virtual machines as is with no downtime, and keep the virtual machine IP intact. Now, by doing this, keep in mind that your router hasn't changed. Your default gateway is still on premises, while the layer 2 extension is up and running. So if we look at a traffic flow, let's say that this virtual machine 172.16.30.11 wants to communicate with the virtual machine on premises of 172.16.31.11, that traffic is going to go across the layer 2 extension, and your on-premises gateway is going to be doing the routing to get to its destination. Now let's look at another flow. Let's say that I have this VM, .11, and it wants to communicate with the virtual machine on the red subnet, which is on a different segment altogether. Now that traffic has to go across the layer 2 extension. It gets routed on the on-premises gateway. It gets sent to your edge router on premises across the express route to the Microsoft Enterprise Edge, where you have your express route terminated across the Azure backbone and into the tier 0, into the tier 1. Now, things to take into consideration with this approach is latency. Depending on where your AVS environment is in respect to your on-premises environment, you have to basically get that latency and multiply it by 2, because we're going across that interconnect twice. So you got to take into consideration your application and its latency requirements. Some customers that have this layer 2 extension, they often complain that the latency is too much. And even though you have two virtual machines residing on the same ESXi host on AVS, the traffic is going to be hairpinning. Now, there are options that you can take to mitigate some of this latency, and that is mobility optimized networking. And that's a very big topic that I recommend that you familiarize yourself with before going down this path. But effectively, what MON does is it injects /32 routes to a particular destination subnet, in which we can say to NSX, if you see that two virtual machines are enabled with mobility optimized networking, go ahead and send that traffic locally, as opposed to sending that traffic back to on-premises. So for example, if you have a latency of 5 milliseconds to your AVS environment, now that latency is not going to be 10 milliseconds with a hairpinning approach. It's only going to be sub-millisecond latencies because that traffic now is staying local within your software-defined data center. Again, there's a lot of caveats with MON. Security is the one that comes to play the most. When you do this, you are bypassing your security policies that you have on premises. As you can tell, there's your security stack is on premises, and in here, you have no security stack. You had to implement things like distributed firewalling to make this work, depending on your security requirements for that particular application. So consult your security team and your security requirements before enabling MON. And this concludes the topics that I wanted to cover. I see some questions on the queue, and we'll cover those towards the end of the session. Thank you. Roberto, back to you.
Yeah, thank you, Victor. No, that was awesome information. So we'll address some of the questions at the end. One of the things that we run into when enabling partners on the Microsoft side is that we either run into a lot of VMware expertise at the partner side, or we run into a lot of Azure expertise. So I'm going to talk a little bit on some very basic aspects of Azure networking, especially Azure terminology. For those of you that are not 100% familiar with Azure, and for those of you that are, feel free to just, go grab a cup of coffee while I explain this. But I think it's important just to set the basics of Azure networking for everybody. So let's get started. And Victor mentioned some aspects of putting your MVAs, your network appliances, on things like a VNet Hub or a V1. If you scan this code, it will take you directly into some scenarios that we have as the landing zone accelerator for Azure VMware solution in Azure. But let's discuss some common Azure terminology that maps very well to this discussion that we're having today around networking in AVS and networking in Azure. For those of you that are not 100% familiar with Azure yet, the first item is a subscription, and a subscription is a logical container for your Azure resources that can also serve as an agreement with Microsoft to use one or more Microsoft Cloud Platform or services. Each Azure resource is associated with a subscription. Creating a subscription is the first step in adopting Azure. Therefore, because AVS is an Azure service, in order to deploy AVS, you will need to have an Azure subscription. The second item is an Azure Virtual Network, or VNet. You're going to hear me refer to this as a VNet. And a VNet is nothing but the fundamental building block for your private network inside of Azure. VNets enable many types of Azure resources like Azure VMs to securely communicate with each other, the internet, and possibly an on-premises environment. VNets are very similar to your traditional networks that you operate in your data center, but it also brings you additional benefits of Azure's infrastructure, such as scale, availability, and isolation. The next item is an Azure Express route. And an Azure Express route lets you connect your on-premises networks into the Microsoft Cloud over a private connection with the help of your ISP. You can establish connections to Microsoft services like Azure and Microsoft 365. The next item is the Enterprise Edge routers, Microsoft Enterprise Edge routers, or MSCE. These are just two routers in an active-active configuration. They establish and enable the connectivity for your provider to connect their circuits that are directly into Azure. You can think of this router as the meet-me point between your provider's termination point for their circuit and the Microsoft Cloud. Then the other item is virtual network gateways. They come in two flavors, VPN gateways and ExpressRoute gateways. And they help connect your virtual networks in Azure and your on-premises networks either via VPN or an ExpressRoute. If you have an ExpressRoute, obviously you'll connect to an ExpressRoute gateway. And if you have a VPN connection coming from your on-premises data center, you'll connect to Azure using a VPN gateway. So virtual networks, when you create a VNet, you apply a custom private IP space, IRC 1918, and Azure assigns resources in a virtual network, a private IP from the address space that has been given during the configuration. You can also subnet those VNets, enabling segmenting into one or more subnetworks and allowing a portion of the virtual network's address space to each subnet. Azure resources are then deployed to a specific subnet that is segmented using the VNet address space. Keep in mind that VNets are scoped to a single region or location. You can have multiple virtual networks from different regions that can be connected using virtual network peering, i.e. connecting two VNets together like I have in this slide here. VNets are also scoped to a subscription, so you can implement multiple virtual networks within each Azure subscription and each Azure region as well. Azure ExpressRoute allows you to create, like I mentioned earlier, a private connection between an Azure data center and your on-premises or co-location infrastructure. It has predictable network performance and offers lower latencies than a VPN connection would through the public internet. You can have speeds of up to 10 and 100 gigabits that are supported. It has MACsec support. It's resilient with built-in redundancy and connection uptime SLA. The other thing is internal circuits inside of Azure are also called ExpressRoute circuits. ExpressRoute Global Reach, which utilizes the Microsoft backbone for connectivity between different regions. There's over 200 ExpressRoute partners, including satellite providers out there. So regardless of where your customer's location is, more than likely you can find a provider that can connect your customer's on-premises data center into Azure. Azure ExpressRoute Global Reach allows you to connect on-premises networks via the ExpressRoute servers through Microsoft's global network or backbone. So for example, if you have a private data center in California connected to ExpressRoute in Silicon Valley, and another private data center in Texas connected to ExpressRoute in Dallas, with ExpressRoute Global Reach, you can connect your private data centers together through the two ExpressRoute connections, and your cross data center traffic will traverse through the Microsoft Global Network or backbone. I also mentioned VPN gateways. VPN gateways sends encrypted traffic between an Azure virtual network and an on-premises location over the public internet. You can also use VPN gateway to send encrypted traffic between Azure VNets over the Microsoft network. A VPN gateway is a specific type of virtual network gateway. Each virtual network can have only one VPN gateway. However, you can create multiple connections to the same VPN gateway from different locations. When you create multiple connections to the same VPN gateway, all VPN tunnels share the same available gateway bandwidth based on the SKU of the VPN gateway that you set up. Azure Route Server simplifies dynamic routing between your network virtual appliances, for example, and your virtual network. It allows you to exchange routing information directly through Border Gateway Protocol, or BGP, between any MVA that supports BGP and the Azure software-defined networking in the Azure VNet without the need to manually configure or maintain route tables. Azure Route Server is a fully managed service and is configured with high availability. Like I said earlier, you can think of the route server as a route reflector. It does not add an additional hop to any of your networking infrastructure. Last but not least is Azure Virtual WAN, or V1. And it's a networking service that brings many networking security and routing functionalities together to provide a single operational interface. Some features include branch connectivity, via connectivity automation from V1 partner devices such as SD-WAN or VPN CPE. You can have site-to-site VPN connectivity. You can have remote user VPN connectivity, i.e. point to site. You can have private connectivity via an express route gateway, intra-cloud connectivity for transitive connectivity for virtual networks. You can have VPN express route interconnectivity, routing, Azure firewall, and encryption for private connectivity, and so on. You don't have to have all of these use cases to start using virtual WAN, but you can get started with just one of these use cases and then adjust your network as it evolves. The V1 architecture is a hub and spoke architecture with scale and performance built in for branches, for VPN and SD-WAN devices, users, Azure VPN, OpenVPN, IKEV version 2, express route circuits, and virtual networks. And just to touch upon why all this terminology and all these items that we're going through, we're going to discuss how this all maps out with not just what Victor explained, but also all of these items like route server, etc. Okay, so now you know what ExpressRoute and ExpressRoute Global Reach are. How does all this fit with AVS? On the top left, you see the on-premises data center. You have your edge router, which connects your ExpressRoute circuit to the Microsoft Enterprise Edge router. This is that MIMI point I was talking about earlier of your circuit coming from on-prem. That circuit then gets connected to your ExpressRoute gateway in your Azure VNet or V1 hub, depending on what you're using. And I'll talk in a little bit more detail what a V1 hub is. I already did that. On the right-hand side, though, you see the AVS private cloud or the SDDC. Inside of AVS, like Victor mentioned, all of the networking is controlled and managed through NSXT. When you create an AVS private cloud, a dedicated MSCE, and you see it there on the top right, also gets deployed for your private cloud. And what you see there coming across between the two MSCEs is the ExpressRoute Global Reach circuit, which is the connection that allows connectivity from your on-prem environment to AVS and vice versa. So now anything that you run in AVS can communicate with any VM or physical device you have on-prem. NSXT will learn the routes that you're advertising from your on-prem environment, and any network segments that you create in NSXT will then get advertised via BGP back to your on-prem environment as well. Okay, so I already explained what a route server is, and just keep in mind that if you're using a VNet hub, a route server is absolutely needed. If you're using a virtual WAN or a V1 from Azure, it's not needed at all. And remember, the route server is nothing but a route reflector, meaning if you have a VPN gateway and an express route gateway, it will reflect the routes between the two of them. So let's go back to this diagram here. So I already showed ExpressRoute for AV and AVS for the ExpressRoute Global Reach connection to back onto on-premises. The one thing we didn't do in that previous diagram is establish the connectivity between AVS and your Azure VNet or V1 hub. In the next slide, I'm going to show the connectivity between an on-premises data center and VPN. But in the meantime, you can see that that the MEC that got stood up with your AVS private cloud in the ExpressRoute gateway in your VNet V1 hub is now connected to your VNet hub or your V1 hub. This is the same internal ExpressRoute circuit that gets established here, and then we'll need to establish so that workloads in AVS can talk to workloads that you're running inside of Azure or any Azure service that you have connected to your VNet or V1 hub. It really doesn't matter which one you establish first or second, the global reach or this internal express route. But once you have this express route circuit connected, then AVS will learn the routes from your VNet V1 hub and vice versa. Next, we're going to talk about VPN. So we understand that not every Azure customer utilizes ExpressRoute to connect from their on-premises environment. So if you connect using a VPN connection, again, there's your on-prem environment on the top left. Your router then creates a VPN connection to a terminating point in Azure, which happens to be this VPN gateway I just described earlier. The VPN gateway is part of your VNet or your V1 hub. That in order to connect to AVS there on the right, we'll need to establish an internal express route circuit, just like in the previous slide, between the dedicated MSCE that got stood up for your AVS private cloud and connected to your express route gateway in your VNet or V1 hub. If you use a VNet hub, like I mentioned before, instead of a V1 hub, what you will need is an Azure route server. And a route server, again, is nothing but a route reflector that allows the VPN gateway to learn the routes that the express route gateway knows about. And in this example would be the AVS routes and vice versa. So regardless of what you're using today, an Azure VNet and Azure V1 Hub, and regardless of whether you want to place your MVA in either of these items, then this would be kind of like the basics for that level of infrastructure. Now we're going to pass it over to my friends and colleagues from the Customer Success Business Unit here at Microsoft to talk to us a little bit about using Azure Virtual WAN with AVS.
Hi, my name is Mark Godfrey. I'm a senior engineer on the Fast Track engineering team. And in this session, I'm going to walk you through the routing that's required when you set up a vWAN with Azure VMware Solution and an on-premise data center. We're going to go through the ExpressRoute connections, the ExpressRoute Global Reach connections, and we're going to look at the routing to understand what we're actually doing. We'll look at the route tables on each of these devices. Pre-built in the lab, we've got a vWAN hub. We've got a VNet, an Azure VNet with an app gateway in it. We've got a couple of workloads here, just a couple of web servers, and we've got an ExpressRoute circuit. None of these are connected together. Oh, other than these, of course. So to get started, we're going to build this circuit between AVS and the secured vWAN. And then we're going to see what routes are available. Second piece we're going to build is the ExpressRoute connection to the on-premise data center. Right? So you would think we'd be able to get from on-premise into AVS, but we won't, and we'll explain why. And then in order to overcome that, the third part we're going to do is ExpressRoute Global Reach. And then finally, we're going to enable secure vWAN hub, and we're going to force all traffic in this environment out through this firewall. So to connect the AVS environment to the vWAN hub, we need an authorization key. We get that from going to the connectivity and then click on authorization key. I've already got one built for this, but all you have to do is enter the name and hit create. As soon as it appears, copy the key and then flip over to the virtual WAN, go to ExpressRoute and click on Redeem Authorization Key. At this point, you're going to put the key in, go back to the AVS SDDC and select the ExpressRoute ID. Go back to Redeem Authorization Key, punch that in, automatically associate it, and click Add. A minute or two later, you're going to see updated ExpressRoute connections. If we close this, you're going to see a TNT number. TNT is always used when it's coming from AVS. 0 megabits per second. That's normal. It's actually a really fast connection. It's 40 gig or 80 gig connection. And most importantly, the connection provisioning state succeeded. Now let's take a look at the effective routes. So what routes are being advertised from AVS into this empty vWAN? Select the default route, and you can see we have a pretty small number of routes being advertised here. This includes the AVS management routes, the routes that are defined inside AVS. So what I'm talking about there are these guys, the segments that we've already defined inside AVS, and then the IP addresses related to the services we've started, like the vWAN. Returning to the route table for a second, let's look at this 192.168.100 address. That's one of the VNets that exists, or one of the VLANs that exist inside the AVS environment. And as far as the hub is concerned, that has an AS path of 12076. That represents the ExpressRoute gateway, and 398656. That represents the DMSEE, or the dedicated MSEE device inside AVS. Now let's add the tiered network in and then take a look at the network table again. So we'll go back up to the vWAN. We're going to go to Virtual Network Connections, and we're going to add, so this one's going to be X2, used for testing. We'll choose the hub. We'll choose the resource group, WestUS2, and then the virtual network is used for testing. Leave the defaults all the same and click Create. Now that's successfully added. Let's go back to the hub and look at the routes on the hub again. Choose the default route. And now we should be able to see 10.280.0/22 virtual network connection connected to use for testing. Notice there's no ASN number here. This is directly a VNet connection, so there's no ASN. So now let's build the second part, which is this ExpressRoute connection from AVS vWAN to the MSEE device that connects us to the on-premise data center. And this on-premise data center has a 172.2186.0/24 address. In fact, there's quite a few because this is a fairly big lab, but the one we're interested in is that. So to do that, we're going to go back to the virtual hub, go to ExpressRoute, and redeem another authorization. And this authorization we're going to get from the Building 25 circuit, lab circuit here. Click on Authorizations, and we're going to create a new one called to AVS MG Demo vWAN. Then click on Save. Then we're going to copy the authorization key, go back to Redeem Authorization Key, put it in there. Go back and get the peer circuit. That's this guy here. Click on this and automatically associate this express route with the hub. Click Add. And now we wait for this express route connection to update and appear here in the list of express routes. Once it's finished, click refresh and we'll see it's succeeded as well. We can now go to effective routes, choose default, and this time we're going to download and open up the Excel spreadsheet. And we'll just do a quick sort here. And we're now going to look for that 172 network that would tell us we're receiving routes from the on-premise 172.2186.0/24. So we know we're getting the on-premise routes. In fact, all of these are on-premise routes, but this is the one we're interested in. Now let's go back to the express route circuit that we connected to, and let's look at the route table for that express route circuit. We're going to click on download and then open the file. If we now look for 1040.144.0, we're not going to see it. So looking back at the diagram, even though we have a connection from AVS to vWAN and from vWAN to this circuit, and that's because we don't exchange those routes. And so this is where Express Route Global Reach comes in. So let's configure that now. First, let's switch to the private cloud. We're going to go to connectivity, and this time we're going to choose Global Reach, and we're going to add a connection. The connection here is going to be using a circuit ID and authorization key. And so to get that, we're going to go back to the Building 25 circuit and go to authorizations, and we're going to create one called 2 AVS 2.0 FTA West 2S2 Global Reach. And then we're going to click on Save. Once that's complete, copy the license key, go back to the cloud, type in your key, go back to the circuit description, grab the circuit ID, back to the cloud, type that in, and click on Create. Once it's completed, you'll see we're connected. And now we're going to go back and take a look at the route table that exists on the Building 25 circuit. So we're going to go here, go to Overview, View Route Table, download the route table, open the Excel spreadsheet. And now we're going to see a 1040.144 series of networks. These are the management networks. Let's make that a little bigger. These are the management networks from AVS. So that means the on-premise express route circuit now knows where AVS is. So let's start by opening our jump box up, opening up a browser. This is a jump box that's in Azure, and we're going to check we can actually reach the on-premise environment. So that's going to be an HTTPS. Well, by default, it's going to take us to the AVS vCenter, and that seems to be working just fine. Excellent. And now let's try accessing one that's on-premise. So HTTPS, // 172.21.86.216, and looks like that's working as well. Okay, so that's great. We have access to both from Azure itself. Now let's RDP into an on-premise machine, 172.21.86.14. This is a Windows server that's on-prem, and we will open up Chrome, the vCenter console in the SDDC, the private cloud, and looks like that's working. So just before we leave this area, I'm going to show you one of the common mistakes we see, and that is that customers will build the Express Route Global Reach, give their on-premise connectivity into AVS. They will establish an express route connection to the secured vWAN to give access to their Azure infrastructure, but they fail to put in the express route connection here. And if they don't have that, what happens is you still have a path. So let's remove that for a second. You still have a path through the express route, through the MSE device, down into AVS. And if we take an example, here's the jump box, and the jump box going to AVS. This is to the vCenter console in AVS, 9 milliseconds. The jump box to on-prem is only 6 milliseconds, so that's the correct path going that way. And then the on-premise to AVS over Global Reach, well, that's going to work just fine, about 5 milliseconds. But if you do have this express route in place, the jump box connectivity into AVS drops to a millisecond. And this is really important because if you imagine, this is a very good example and it's only 9 milliseconds compared to 1 millisecond, but I have seen it where it's up to 30 milliseconds slower to go through this path than it is to go through the direct express route to AVS. So just be aware of that. You do need this connection as well. So for the next part of this demo, we're going to take the hub and we're going to convert it into a secure vWAN hub. And you do that by just clicking the Firewall Manager, and you can see we've highlighted the hub we've got what we want here. In this case, it's our demo hub, Azure Firewall, Security Partner Provider. So in this case, we are not using anybody, right? We're going to just use Azure Firewall. We're not using Zscaler, Checkpoint, or iBoss. And click Confirm. And that will start this deployment. This took 9 minutes to complete. Close that, go to Resource, and we can see our firewall here in the vWAN hub. So let's go back to Virtual WANs, go back to the demo vWAN, and you're going to now see we've got a hub. This icon's turned red, and which means it is a secure hub. Click on this, and then select Azure Firewall and Firewall Manager. Click on the blue line, and you're going to see we have our secure hub here. So before we get into security configuration and what the issue that routing intent solves, let's take a step back and look at what happens when we look at a machine that's inside the AVS environment trying to get to the internet. And so to do that, we're going to go to our jump box. And in the jump box, I've logged into the vCenter server, gone to the server 01, and then launched the console. And you can see if I try to get to the internet at this point, nothing's going to happen, right? It has no path out. And that's what routing intent is going to solve. It's going to advertise a quad 0 route to everything that it's connected to the vWAN hub, telling everything that requires an internet access to go to the Azure Firewall. So in this case, we're going to choose Internet Traffic, Azure Firewall, and save. It's definitely worth reading this message. Please note that securing internet traffic will cause the vWAN hub to advertise the default route, in other words quad 0, to the internet with next hop as Azure Firewall. This will disrupt internet connectivity for all hub connections and must be done during maintenance hours to avoid impact to production workloads. Do you want to continue? Yes, or okay in this case. So while we're waiting for this, is this going to solve my problem for AVS workload machines unable to access the internet? So once that is completed, you're going to see that the connections, VNet connection and the 2 ExpressRoute connections, are all protected by Azure Firewall. So if we went back to the jump box, and I now type in cnn.com, am I going to get anywhere? And the answer is going to be no, because we still haven't configured the firewall to actually allow traffic through. The default policy is deny. So now we have to create a policy. So in the blue search bar, type in firewall policies. And we're going to go create. The resource group is going to be when we're building all this stuff in. The name is going to be demo to internet. The region will be West US 2. And it's going to be a standard tier. And there is no parent policy. DNS settings, we're not using DNS. We're not going to use TLS. Next, we're going to do rules. So we have to add a rule collection. It's going to be demo to internet rule. It's a network rule. And we can set this at 300. Just an order of precedence. And then demo rule, IP addresses. So it's going to be all IP addresses, all protocols, any port, and to any IP address. So basically we're creating a rule that says allow anything. Add, review and create, and create. When it's complete, go to Virtual WANs, Demo WAN, open up the hub, go to Firewall Manager on this guy, open up our secure hub, go to Security Providers, click on Add Policy, and we're going to choose our Demo to Internet Standard policy. Click on Save, wait for the updating associations to complete, and we should be good to go. So if we flick back over to the server we have running inside AVS, and we type in ipaddress.com, it's 2232.47.98. That looks good. Type in cnn.com, and we're getting through to CNN. Last thing we're going to do, we're going to check this 230.247.98. and make sure that that is our Azure Firewall IP address. And the way we do that is to switch back to our portal, click on Public IP Configuration, 2230.247.98. We have now configured our environment to talk out to the internet via the Azure Firewall in a secure vWAN hub.